Dear children, in this video we are going to derive a formula called lens formula. In the earlier videos we discussed ray diagrams of the image formation for the location of different objects. Here let us discuss the ray diagram first and then we will go for the derivation. Now in this ray diagram, O1 is the location of the object and I1 is the location of the image. So when we draw ray diagram, when the object is just beyond 2f2, image will be formed between f1 and 2f1. Now in this triangle, in this diagram, O1 is object, P pole, f1 focus, and f2 is the focus on the other side, and 2f1 is the double of focal length, and 2f2 is also double of focal length. I1 is the image. Now in this diagram we can observe that two triangles are similar to each other. They are P'(F1), that is P'(F1). This triangle is similar to F1I'. Why they are similar? First, from the figure you can observe that these two angles are vertically opposite and they are equal to each other of these two triangles, and this is right angle and this is also right angle. If two of the angles are equal in both the triangles, so automatically the third angles, the set of third angles are also equal. As all the angles are equal, these two triangles are similar to each other. So therefore triangle P'(F1), P'(F1) is similar to F1I', F1I'. So as these two triangles are similar, the ratio of the corresponding sides are equal. Therefore PP1, that is PP1 by I1 is equal to PF1 by F1I. But from the figure you can observe that F1I, that is this distance, is nothing but Pi total distance minus Pf1. See, F1I, that means this distance is equal to Pi, this total distance, minus Pf1. Now by substituting Pi minus Pf1 in place of F1I, we get the ratio Pp' by I' is equal to Pf1 by Pi minus Pf1. Let this be equation number 2. Now two more set of triangles are similar in this diagram. They are O'P, that is O'P is similar to Pii', that is Pii'. Again these two set of triangles also similar to each other as the corresponding angles are equal. That is, these two are vertically opposite angles, these two are equal, and this is right angle and this is also right angle. So these two set of angles are also equal. So automatically third set of angles are also equal. As the angles are equal of both the corresponding angles of both the triangles are equal, these two are similar. That is triangle O dash P is similar to PII dash. So as these two triangles are similar, the ratio of the corresponding sides, that is O dash by II dash, O dash by II dash is equal to PO by PI. PO by PI. But O dash is equal to, this is O dash is equal to P dash. So we can replace O dash with P dash by II dash is equal to PO by PI. Let this be equation number 3. From 2 and 3, by observing the second equation and third equation, what we can conclude? See, P dash by II dash is equal to Pf1 by Pi minus Pf1. Here P dash by II dash is equal to PO by PA. So by comparing LHS and by equating RHS, we get PO by PI is equal to Pf1 by Pi minus Pf1. Now from this, if you want to get Pi by PO, by reciprocating these fractions, Pi by PO is equal to Pi by Pf1 by Pf1. Now, separating the denominator for the, separating denominator in this fraction, Pi by PO is equal to Pi by Pf1 minus Pf1 by Pf1. So Pi by PO is equal to Pi minus Pf1 minus 1. Now by dividing the equation with Pi, so by dividing the entire equation with Pi will be cancelled. So 1 by PO is equal to 1 by Pf1 minus 1 by Pi. Now by bringing 1 by Pi to the LHS, 1 by PO plus 1 by Pi is equal to 1 by Pf1. One by PO plus 1 by Pi is equal to 1 by Pf1. Now, what is PO? PO is nothing but object distance. It is generally represented by U. And Pi is image distance. It is generally represented by V. And Pf1 is nothing but, it is focal length, generally represented by F. Here, PO is the object distance, Pi is the image distance, Pf1 is focal length. Now, according to sign convention, so what is sign convention again? Here, all distances to be measured from pole only. Now, that's why we wrote PO, taking as P as the main center. We have to measure distances from pole. So PO is object distance, Pi is image distance, Pf1 is focal length. Now sign convention. So all the distances to be measured from pole and the distances measured against the incident ray are taken as negative. So PO, we are measuring the distance from this side to this side, but the incident ray is in this direction. That's why PO is to be considered as minus U. Remember this thing. So if the distance is measured against the incident ray, it has to be considered as negative. That's why PO is equal to minus U and Pi is equal to V. See, this is the incident ray and the distance is also, so this is the direction of the incident ray and the distance Pi is also measured in the same direction as incident ray. That's why it is considered as positive. Similarly, Pf1 is also positive. Now PO is equal to minus U according to sign convention Pi is equal to V, that is plus V. P upon is equal to F, that is plus F. By substituting PO, Pi, P upon in the above equation, that is 1 by PO plus 1 by Pi is equal to 1 by P upon. Now we get this equation, that is 1 by minus U plus 1 by V is equal to 1 by F. By rearranging these, we get 1 by F is equal to 1 by V minus 1 by U. This formula is known as Lenz's formula. Remember Lenz's formula, that is 1 by F is equal to 1 by V minus 1 by U, where F is focal length, V is image distance, U is object distance. By knowing any of the two values in this formula, we can obtain the third value. This is very important formula. This formula is known as Lenz's formula. Remember for the exam point of view. Thank you.